solve this related rates problem or I'll rob you.
But, I don't even know what related rates are.
Silly Nathan, you should have paid attention in calculus all those years ago instead of playing Tiles with Friends, the hit game on the App Store.
Alright, today class we're going to be learning about
related rates.
For example, say that you're walking down the street and you come to a lamppost, and the lamppost is 20 feet tall and you're 15 feet away from it. Let's say you're moving away at a constant speed of 5 feet per second, and you want to know how fast your shadow is growing. Here we have to use a related rates problem. So here are the steps to learning a related rates, and the first step is write down what you know. So in this situation, what we know is that we're moving away from the lamppost at
speed
of 5 feet per second. And since we call the distance from a lamppost, our distance from the lamppost, x, the rate of change of that, or dx dt, is equal to 5 feet per second. Which brings us to step 2, which is to write down what we want to know. Since in this problem what we want to know is the speed at which our shadow is growing, and we call the length of our shadow y, we need to know the rate of change of that, or dy dt, in feet per second. Which brings us to step 3, which is to relate the two things in a differential equation. So in this situation, we know that these two triangles are similar because
the angle postulate.
We can say that y, this distance y, divided by this distance 6, is equal to the ratio of this distance x plus y divided by this distance 20. And now since we have this equation, we can just rewrite it, and it ends up just becoming something really, really easy, which is just 6 over 14x equals y. Alright, so now that we have this equation, we can just differentiate both sides, which gives us exactly what we want, dy over dt, which is equal to 6/14 of dx dt. Alright, and now that finally brings us to the last part of our steps, which is just to plug in what we know and solve. Now we know that dy over dt equals 6/14 of dx dt, but we already know dx dt, and we know that's 5 feet per second, so we just plug that in, times 5 feet per second, and then just solve it through, which ends up giving us dy dt equals 30 divided by 14, or
as a decimal approximation to 3 places,
2.143 feet per second. Nathan, are you playing Tiles with Friends again?
Yeah.
Come on, stop it. Pay attention. A problem like this could save you from a ninja one day, you know.
Yeah.
Tiles with Friends available in the App Store.
Ha, silly ninja. I remember how to solve this kind of problem. The answer is 2.143 feet per second.
Drat. Foiled again.